This is preparing for the ACT 2021-2022, Passage 1 of the Science section. If you have a particular problem you want to go to, you can just click right through the chapters to find that particular question. So this passage is talking about large rocks that have moved along the surface. So that's kind of what we're talking about here. And what we have is we have three different explanations from scientists 1, 2, and 3 about how those happened. So scientist 1 makes mention of the fact that snow melt runs down and collects, and as the cold temperatures freeze, they freeze around the rocks, and the ice melts. It creates a layer of mud. That's important. And the ice rafts around the rocks. And the buoyancy floats the rocks on top of the mud. And then as it goes down, it says the trails left by the rocks are shallow and only about 2/3 as wide. And they give us the combination of ice, mud, and light winds. So that's what scientist 1 believes is the cause for why these rocks move. Scientist 2. Again, we mentioned snowmelt from the surrounding mountains. However, it does not get cold enough for ice to form. So that's a difference between scientist 1 and scientist 2, is that in this one it says the waters freeze around the rocks, whereas scientist 2, it says it does not get cold enough for ice to form. And so when we look at these, we want to find out not only what are the similarities, but what are the differences. So here's a difference right here. It says when the surface gets wet, the top layer of clay transforms to a slick, muddy film. So we have a layer of mud, but it also says dormant algae shows up. So not only do we have mud, but we have this algae growing. But it also says strong winds are required to push the rocks. So this one gives us a combination of mud, algae, and strong winds is what causes these rocks to move. And then scientist 3, it says water does collect, producing mud and ice. However, neither mud nor ice is responsible. The playa is located along a fault line between tectonic plates. So with this one, no mud, no ice. So shifts cause the rocks to move downhill, leaving the trails. So it says combination of tectonic plate movement and strong winds. All right. So question 1 says, according to scientist 2, friction between the rocks is reduced by which of the following? So when we read this, it says friction is reduced. That means made more slippery. So let's go back to scientist 2. Now scientist 2 says that we have a slick, muddy film and dormant algae are coating the rocks that causes the clay to become wet. And it says it actually right here. The presence of mud, and algae. Presence of mud and algae reduce friction between the rocks and the clay. So oftentimes you'll have a question where you just look at the phrase and that right there will tell you what the answer is. So that phrase right there, that clues us in as to why the answer was letter D for number 1. All right, number 2. Suppose a researcher observed that wind speeds greater than 80 miles an hour are needed to move the rocks. So this observation is consistent with which of the following explanations? So here we're talking about winds greater than 80 miles per hour. Now that's a pretty high wind. Now let's look back, because we didn't highlight anything about wind with these scientists, but let's take a look. Scientist 1, they mention light winds. Scientist 2 mentions strong winds. And scientist 3 also mentions strong winds. Well, here's a question where you actually have to know a little something, that 80 miles an hour, well, that is a pretty strong wind. So since that's a strong wind, the only examples of scientists that believe that you're going to need strong winds are Scientist 2 and Scientist 3. So that means that that's why letter H is the answer to that question. Number 3, suppose that no seismic activity was recorded. Now, seismic activity, this is another way of saying something to the effect of something like an earthquake. That would be an example of a seismic activity. Now, which scientist would make mention of vocabulary like this? Now, here's an example where the exact wording is not going to show up, not like question 1 where the wording was exactly the same. But which scientist talked about seismic activity, earthquakes? Well, that's down here with Scientist 3 because they made mention of fault line between tectonic plates. So that's a case where, okay, tectonic plates, that's what causes earthquakes. That's what causes seismic activity. No one else, neither Scientist 1 nor Scientist 2, makes any mention of tectonic plates or seismic activity or earthquakes. And so that's why Scientist 3 is the only one that makes mention of that. And so it's saying no seismic activity was recorded. Well, Scientist 3 is saying that you need seismic activity, that is, you need those fault lines in order to make the rocks move. And so that weakens his Scientist 3's argument. If you chose answer C, it actually strengthened theirs. Because they don't believe that earthquakes are necessary. But Scientist 3, he does think that earthquakes are necessary. So if they're not there, Scientist 3's argument has now gotten worse. Number 4, suppose it was discovered that a particular rock formed a 200-meter long trail in 72 hours. Would this discovery support Scientist 1's explanation? So, we have 200 meters in 72 hours. So the question is, what kind of description does this scientist talk about when it comes to how far the rocks are able to move and in what time frame? And let's change color. And it says right here, the rocks are able to move several hundred meters in a few days. Well, right here, several hundred meters, that counts in a few days. And let's do this. 24 hours is 1 day. 48 hours is 2 days. 72 hours is 3 days. So that definitely fits the description that it says up here, in a few days. Now let's contrast that with the other scientists. Scientist 2 said that the rocks are able to move several hundred meters in a few hours. Well, that doesn't work because we have 72. A few hours is 2 or maybe 3. That doesn't work. And then Scientist 3 says the rocks are able to move only a few meters over several years. So a few meters? No, we have 200 meters. Several years? Sorry, time frame doesn't work. We have 72 hours. So that's why, yes, this works with scientist 1. Because, like we said, the scientist 1 indicate that rocks can move several hundred meters in a few days. That's a copy and paste of what the scientist number 1 said. Okay. So, looking on to question 5, we'll have to bounce back and forth. That's okay. Suppose that during 1 year there was no measurable movement in the rocks during the spring. Now, it looks like the key phrase here is during the spring. We'll come back to that. Scientists 1 and 2 would most likely agree that this was due to the absence of which of the following. So if we look at our options, we've got algae, snowmelt, strong winds, sub-zero temperatures. Now let's look back at where this happens. This happens in a relatively flat, dry desert basin. So during the spring, what do we know doesn't happen? Well, we know there aren't sub-zero temperatures, but scientist 1 and scientist 2, they don't agree about temperature, do they? Because scientist 2 says it does not get cold enough for ice to form, whereas scientist 1 says this water freezes around the rocks. So sub-zero temperatures isn't something that they would agree on. But what they would agree on is the fact that, well, strong winds? No. We already talked about that. Scientist 1 believes that there are light winds, and scientist 2 believes that there are strong winds. So that is definitely out. Algae? Well, scientist 2, excuse me. Scientist 2 mentions algae, but scientist 1 makes no mention of that. So algae doesn't even enter in to scientist 1's explanation. So scientist 1 wouldn't say that's the reason why it happened. But they both mention the fact that there is snowmelt going on. Okay. Because they both mention in the spring. There's the key phrase right there. In the spring, snowmelt. The surrounding mountains runs downhill and collects. Right here, snowmelt, the Falling Mountains does collect in the playa during the spring. Right there. So the fact that it was in the spring, that keyed us into this phrase right here. So in this one, problem number 5, it was snowmelt because it was during the spring. So that's why the answer was letter B. Number 6. This one says, suppose the air temperature varies between 4 degrees Celsius and 47 degrees Celsius. So here's one thing where you have to know a little bit of outside knowledge. And that is, 0 degrees Celsius is freezing point of water. And then 100 degrees Celsius is the boiling point of water. So we are clearly in between that, between 4 and 47. That means that this is telling us that it is always a liquid, never ice. So the question asks, would this information support the explanation of scientist 2? Well, if we look at our answers, can ice form within these temperatures? Well, no, it can't. So that means we can eliminate letter G and we can eliminate letter J because ice cannot form. But it still leaves the question, would this support the explanation of scientist number 2? So if we go back to scientist number 2, he says it does not get cold enough for ice to form. This is what we circled at the start as we read this. So that means then that, yeah, it doesn't get cold enough for ice to form, and scientist number 2 would agree with that. So that's why the answer is letter F. And then number 7, based on scientist 1's explanation, a rock trail that is 33 centimeters wide was most likely made by a rock with approximately what width? So here we got to go back to scientist 1, and there's something about the width of the rock trail versus the width of the rock. So if we go back, let's see. So as I skim through this, the key phrase that I'm seeing comes in right about here. Right here. About 2/3 as wide. Let's see. Trails left by the rocks are about 2/3 as wide as the rocks themselves. That's the key phrase. So what we have to do is we have to say, all right, whatever the width of the rock is, width of rock, if we multiply that times 2/3, we should get 33. That's what we ought to get. All right. Now, a little bit of math here, but on the science section, you shouldn't be reaching for your calculator because, well, they don't allow you to use it. So what you want to do is you want to be rounding as best you can. So I'm going to multiply this 3 over. So 3 times 33, well, 3 times 3 is 9. So that means we get 99. So width times 2 is 99. But what I'm going to do is I'm going to cross that off. And I'm going to make it a round number. I'm going to make it 100. Because we can approximate. It says it right there, approximately. So we can get our numbers close. So now, I'm going to take that 2 over and divide by 2. And that gives us our width of about 50. And that's why the answer is letter C. Thanks for watching. Stay tuned for the next one.